Hello students, welcome to BTech first year bridge course. In the last lecture, we have introduced the concept of electric potential and the relation between electric potential and electric field. Now today, we will discuss about the choice of reference point for finding out the electric potential. Now what is reference point? The point with respect to which one have to find out the electric potential. That is called the reference point. Now, one can have ambiguity in choosing the reference point since the choice of the reference point is very much arbitrary. Now, here the reference point is shown as tilted O because it is a very special point. Now, why it is special? That is the discussion of today's class. Okay, so when the reference point is at this tilted O, the potential measured at r distance from the point where the charge is situated, and this is the form of the potential. Now, if we change the reference point from this tilted O to tilted O prime, the new electric potential at this point will be of this form. Now we can write it as the combination of these two integrals. Now the first integral is actually coming out as a constant which is k. Okay. So the new potential is differed by a constant from the old potential. Right. Now if we find out the potential difference and the gradient of potential, those are independent of choice of reference point, because adding a constant to the potential will not affect the potential difference between 2 points. That is why all such potentials differing only in their choice of reference point correspond to the same electric field, because you know the gradient of potential is actually the measure of electric field. Right. Now let's discuss some example on the choice of reference point. Here we are considering a positive point charge q. Now to move a unit charge from this A point to B point, the work done is measured by this equation. So this we have discussed in the last class, one of my last classes, right? Now this will give us the measure of potential difference between A point and B point. And here this small k is actually is this constant 1 by 4 pi epsilon naught, right? Now the reference point can be considered as the earth or a point at infinity where the potential is 0. So you can choose a reference point on your own way where the potential is 0. Okay, so reference point is very much arbitrary. You can choose it as earth is your reference point, or the point at infinity is your reference point, because at infinity the potential is 0. Okay, so if we choose the point B is at infinity, the potential at A point becomes like this. Okay, as the potential at B point is 0, because we are considering this B is at infinity, right? So in general the potential at any point can be written like this. Okay, now problem arise if choice of reference point is a point at infinity in case of planar charge distribution. Now let's understand that. Now to find out the potential, we need to find out the electric field, right? And using electrostatic Gauss's law, we can find out that, right? So we have to construct a Gaussian pillbox which straddles this surface, charged surface. If the area of this flat surface of the pillbox is capital A, then the total flux will be electric field, magnitude of the electric field multiplied by 2 times of the area of the flat surface, right? So here this sigma is the surface charge density of this planar charge distribution. Okay, so the total charge enclosed by this Gaussian surface is sigma into A. Okay, so we get the form of the electric field like this, sigma by 2 epsilon naught. Now to find out the potential, suppose at z distance from the charge surface along z axis, we want to find out the potential. So in that case, if we choose the reference point is at infinity, then the potential at z will be calculated like this. So here this is that electric field sigma by 2 epsilon naught dz, then minus infinity to z, right? Then if we integrate, this will come out. So the value of the potential here is infinite, right? Infinitely large value. So here is the problem. The potential cannot be infinite. So what is the remedy? The remedy is simply to choose some other reference point. As I told, the reference point you can choose on your own way where the potential is 0, right? So here on this surface the potential is 0, okay, because here this is sigma z. If you put z equal to 0, your potential will be 0. So the remedy here is to choose a reference point where the potential is 0, and that is actually the origin. So here we have to use origin as the reference point. So in that case the potential will be Vz is actually minus sigma z by 2 epsilon naught, right? So today I am concluding the electric potential in this class. In the next class, we will discuss the importance of Poisson's equation and Laplace equation to find out the electric potential. Okay, thank you.